Let's see. Is it coming up? Oh, it helps if I actually click on the thing. Where did it go? Oh my gosh, sorry guys. Having issues. Ah, there it is. There's the board ski. So you guys are just gonna follow along home. You guys in class are obviously gonna follow along. So we're just looking at that problem set. We are gonna do 1 through 4, so that's not too bad. Just as a reminder of what we were doing before vacation. And then there will be a few for you guys to try. I think I have you try up to 12 to kind of end class out, and then we'll pick and choose some tomorrow as well. So we might not get to every problem, but a lot of them are kind of similar to each other. So that will be good practice. So we'll see what you remember. If you remember nothing, I'm not judging you because I can barely function right now. Yes? Oh, absolutely. Anytime. So let's just kind of do these. We'll see how we're feeling. If you are at home and you have a question, you're more than welcome to interrupt me, or I do have my chat up. You can go ahead. I can
Questions?
Yeah.
On the day before you let them know, I wasn't here for the test or in person,
okay.
And then I thought we were gonna come back, but then we went home.
We'll figure it out in a few minutes. We'll figure something out soon. Yeah, if you're at home, feel free to interrupt me, or I have my chat up. I have my 2 screens up so I can see both. So I'm happy to help you, and I'll kind of check with you. So if you can't see the screen or my writing, just let me know. I know it's a little reflecty with the lights, but we'll do our best. I hate sitting at my desk with a stupid projector thing. So. All right. I'm sorry in advance because I tried to make more room for you, and then it was a PDF, and I gave up because I was getting frustrated. So if you know you're a person that likes to give yourself some space, you might want to do these on a separate sheet. Whatever works for you works for me. The main one is to practice a little.
Anna Berry, please report to the main office. Anna Berry, please report to the main office.
What I've learned today is Z's and 2's are highly irritating to do together, but we'll just do our best. It drove me nuts before. That's why I put the line through the Z so it doesn't look like a 2. So our main goal today, and in general, is we want to solve these equations. All of the equations will have fractions, which are kind of annoying. So our main goal is let's get rid of the fractions so then they're a little bit easier to solve. Depending on the problem, you can do a few things. You can always multiply everything by the common denominator, and that will kind of take care of your fractions for you. If you see a setup like this, this is called a proportion, so we can just cross multiply these ones. So depending on what you see, you can kind of do a few different things. I like cross multiplying, I just find it easy. But once again, if you have more terms, it doesn't work. But for this one, let's just do a little cross multiplying. So that's always a good option if you just have a fraction equals a fraction with nothing else up there. So if I cross multiply that, I get 2z minus 3 times 2z minus 3. Okay, so I cross one way. I put an equal in the middle, and I cross the other way. And I get z minus 2 times 2z plus 3. So if it is set up like a proportion, cross multiplying will take care of the fractions for you, which is delightful. Just making sure I can see that. And now we can do some solving. So to solve, we have to simplify. So on the left side here, I'm going to do some distributing. That will give me 4z squared. And then what would that be? Minus 6, so that's negative 12z, minus 12z, plus 9. Okay, so that side's distributed through. And I'll do the same thing for the right side. I get 2z squared. What would that give me? Plus 3 minus 4, which would be minus 1z, minus 6. So our main goal as we're solving these is kind of just look at your setup. When you see these squares, we call those quadratics, we were nice. There's a lot of ways to solve quadratics. We made them all factorable. So later in the year, again, next chapter, we'll do the quadratic formula again and all that fun stuff. But we showed some mercy on you and made these all factorable. But in order to factor these, if you see quadratics, you do need to set it equal to 0. So I'm going to move all these terms over here, and I'll just kind of line them up with their like terms and combine them. So I'll move the 2z squared. I'll add 1z. So I'm just kind of lining things up, and I'll add 6. So once again, that right side is now equal to 0. And I'll kind of just combine things here. That would give me 2z squared minus 11z plus 15. And once again, when we get to this point, this will be factorable for now. So we're going to factor it. I feel like we've factored our little brains out this year, so this shouldn't be too bad. So that would be 2z and z, 15, 5 here, 3 here, right? Because that would give me 6 and 5, and if they were both negative, that would be negative 11. Excuse me. And then we actually have to solve it. So to solve it, you just take your binomials, set them equal to 0, and then find what your missing variables are. I feel like we've done that step a million times this year. And in this case, I do get 2 answers. My 2 answers are z equals 5 over 2 and z equals 3. So sorry if I'm in the way, I will move. Now, does anyone remember what we have to do for every single problem when we're solving rational equations? Yes.
Plug them back in.
You always have to plug them back in and check them. The main thing is you have to check them. Because sometimes you'll find an answer and then you'll plug it back in and it will maybe be one of our domain restrictions. So that's the main thing. You just want to make sure when you plug it back in, you don't get a 0 in the denominator. So if I plug in 5 over 2, I should be all set because the domain restriction here should be negative 3 over 2 and here should be 3 over 2, and those were neither of our answers. So plugging those back in, you can do it in a few minutes, or you can use your calculator, but both of those will work. So always make sure you are checking your answers. And that is an important part of solving.
So you can just plug it into like the bottom?
Yeah, you kind of just make sure it's not against a domain restriction. Yeah. So I'm gonna leave that up for a second just because I'm using this one section of board because of the camera. And I don't want to rush people, and I know people at home are writing. So feel free if you see something, ask. We're gonna do 2, 3, 4, so not too terrible. And just make sure we're okay with those steps. All right. I know we have a lot of people, obviously cohort B's at home, but there's some people quarantined. Or if you end up getting quarantined, just always remind me because I just can't keep track of anyone anymore. So if for some reason you're not here and you're supposed to be, just let me know so I can make sure you get all the info. I think I'm good with that. Okay. Anyone have questions with 1? 1, no. Okay. So let's look at 2. So that one, I like proportions. They're nice. You don't have to do it too much. We're familiar with that setup from like back in the day. But unfortunately, they're not all proportions. So when they pop up, they're nice. But number 2 is not a proportion because we have more terms there. So let me write that out. Okay. So since we have more terms, we can't do cross multiply. There's too many things going on. So in this case, we are going to multiply everything by the common denominator. I always remind myself off to the side, what is the common denominator? If you can kind of do it in your head, go for it. I'm just like, I like to write everything down so I don't lose stuff. So find the common denominator. Remember, just everything needs to be represented. So I'm definitely going to need an x minus 5. I'm going to need a 2, so I'm going to kind of write it like that, 2 times x minus 5. And then that x minus 5 is already represented. So this would be my common denominator, 2 times x minus 5. So I'm going to multiply every single fraction by that. So I go back to every fraction, and next to it I write times 2 times x minus 5 times 2 times x minus 5 times 2 times x minus 5. So that will hopefully reduce some things and make it so we don't have fractions. That's always the main goal. So in this first fraction, the x minus 5's cancel. I have 3x minus 7 times 2. Since I'm multiplying a binomial, they would both get multiplied by 2. And I'd be left with 6x minus 14. All right, then we got a little plus. In here, the 2's would cancel, right? And I have x times x minus 5, so I'm going to distribute that. And I'll get x squared minus 5x. And I got my equals. And over here, the x minus 5's would cancel, and I'd just be left with 16. I like that step. It feels nice to cancel things. Looks a lot nicer. No fractions left. So now our main goal is I do see a quadratic. I do see that x squared. So I want to put it in standard form equal to 0. So I'm going to put this x squared term first. I'm going to combine these x terms because they're just on the same side. That will give me 1x. And then I'm going to move this constant over here, and that will give me minus 30. And now since nothing's left on the right, I would say equals 0. But once again, all the quadratics, if you see those x squareds, it should be factorable. So we are going to factor it. So that's x. 30 would be plus 6 minus 5 when I factor it. And now when I solve it, I get my two answers. X equals negative 6, x equals 5. What do I notice?
5 does not work.
Yeah, 5 doesn't work when you plug it back in. We call it an extraneous solution. Yeah, I don't do something to just show me it doesn't work. Go like this, write extraneous. Remind me that this does work, be aggressive about it. But I should be able to tell, oh, you did solve for it, but when you plug it in, it doesn't work. So it is not a solution to that problem. The only solution to that problem is negative 6. So I should be able to see that as you're showing your work for stuff. So that was number 2. So once again, those extraneous solutions just kind of pop up. So it is important that you do check your answers. Any questions with 2? Yeah.
Wait, where does it not work?
Because of 5, x minus 5.
Oh, in the denominator.
5 minus 5 would be 0, so then it wouldn't work, and that would be a big mess. So we don't want those 0 denominators. Any other questions on 2 or anyone at home? Sorry, I just said these now. Okay, beautiful. We're halfway done. That's what we need to do. Great. Number 3. Let me just write it out. Sorry, I always like to. I'm a rusher. I like to make sure I write it correctly. All right. So I look at number 3, not a proportion, so I'm going to have to find the common denominator. So I just kind of go through each denominator. I have an n minus 3, I have a 6. I am going to factor this one because there's a GCF, so that would be 4 times n minus 3. Okay, so just make sure everything's factored again. So I see I'm definitely going to need an n minus 3. Okay, because that represents there and there. And then we have some constants. We have a 6 here and a 4 here, so we just want the least common denominator, which would be 12. So my common denominator between all those would be 12 times n minus 3. And then from there, we just go back and everything gets multiplied by 12 times n minus 3. So it's important that you get that common denominator. So then this step works. So I always like to write it out. So let's see what happens. N minus 3's cancel, and I'm just left with 12n. Okay, so that wasn't bad. Over here, that just reduces, right? 12 over 6 reduces to 2. Don't get freaked out because you have 3 things. So I have n minus 2. And I have a 2. I always put there's just a number in front. And I have n minus 3. So we know with multiplication, the order doesn't matter. So if I just have a regular constant, I put that out in front. Pick 2 things to multiply. I usually multiply these 2 things, the distributing, to get n squared minus 5n plus 6. And then remember to actually multiply that by 2. And that would give me 2n squared, sorry if I'm in the way, I will move, minus 10n plus 12. So once again, you add n minus 2, and then you add a 2 from reducing that, and then n minus 3. So if you have 3 things to multiply, I just pick 2, multiply those, and then distributed that constant. And then over here, what do we got equals? The n minus 3's cancel. 12 over 4 reduces to 3. And I'd be left with 15n minus 3. Okay, I see a quadratic. Once you see an n squared, you have to kind of get into the mind frame that this is going to be factorable. In order to factor it, I need to put it in standard form, set it equal to 0. So I'm going to put this quadratic term first, if I can talk. Okay. And then what do I have? I have 12n minus 10n is 2n. And then I'm going to subtract that 15n over here as well. So 2 minus 15 is negative 13. Okay. And then I'm just going to move this constant over here to give me plus 15. All right, so standard form, so everything's combined all on one side. Make sure it's equal to 0. And then we get into our good old factoring steps. I feel like we keep having the same numbers, but what do we have? 2n and n. That would be 5 here, 3 here, and if they're both negative, so that's negative 2 minus 3, yeah, beautiful. There you go. And then you can solve those, you can do those quick. N is going to equal 3 over 2. N is also going to equal 5. I do a quick check and see would that go against any restrictions? No, that should be good, right, once I plug that back in. So that would be my final answer. So in this case, both of them work. Sometimes they both work, sometimes they don't. Just depends on the problem. So once again, I'm just going to give people a second. Because I know people are copying. Any questions on 3? Anyone in class? Oh yeah.
Basically in general, so like it will only not work if it's a domain restriction.
Yeah. Or sometimes it's just a no solution problem, but you would know that as you were doing the problem. But yep. Pretty much. That's my plug back in. All right, one more, and then we'll kind of talk about what we're going to do for the last few minutes of class here. And go from there. So number 4. So number 4 is a fancy one. We have to do a little bit of moving stuff around, and factoring, and all fun stuff. So as I look at number 4, sorry, let me just write it first. All right, so we're all written out. Definitely not a proportion. I need to find the common denominator. In order to do so, I'm going to have to factor all those denominators. So we have to kind of rewrite the whole thing. So I'm going to factor the first denominator, and I'll get what? X plus 5x minus 3. All right, so I'm just kind of rewriting everything just with factor denominators. And then over here, what we got? X minus 3x plus 2. Just focusing on the denominator. And then over here, we got x plus 5, x plus 2. Whew. All right, so now that that's happened, and we're kind of used to doing that stuff, we've done that a lot. Just comparing things in general, you need to factor a lot. So we just look, okay, in my common denominator, I'm going to need x plus 5. I just go through each one. I'm going to need x minus 3. That's already represented, and I'm going to need x plus 2. And then that's represented. So we have 3 binomials that we're going to have to use in our common denominator. Just kind of going through and making sure everything's represented. So now, like I like to write it out every time. If you're getting lazy, I don't blame you. But I write the common denominator next to every one. X plus 5, x minus 3, x plus 2. X plus 5, x minus 3. X plus 2. X plus 5, x minus 3, x plus 2. Okay, whew. I'm starting to hurt today. So now we'll see what cancels, what are we left with, how do we solve it, all that fun stuff. So here, x plus 5 cancels, x minus 3 cancels. I'm left with 4 times x plus 2, so I'm going to distribute into that to get 4x plus 8. All right, so we just keep going. Plus x minus 3 cancels, x plus 2 cancels. Excuse me. Distribute in, I'll get 5x plus 25. Let me equal sign. What do we got? X plus 5 cancels, x plus 2 cancels, so I have 3 times x minus 3. That will give me 3x minus 9. Beauteous. Now, there's no quadratics. There's no x squareds. We just need to solve for x. So we got all the x's together, and then you kind of just solve for it. So I combine my terms on the left side just to kind of make things a little bit nicer. What do I get? 9x plus 33. So you're just combining, getting your x's together. You can probably combine a few of these steps. I'm just kind of showing you my process. And now I'm still just solving for x, just trying to isolate it. This is actually kind of not too bad, negative 42. So x is going to equal negative 7. So actually in the end, you didn't even have to factor anything. It was just really isolating that x with that one answer. And if I plug that one answer back in, it will work, right? Because there's no domain restrictions based off of it. So that one, there was a little bit more to the setup part of it. Just getting the denominators factored so you can find the common denominator, but the actual solving wasn't bad. And some of the other ones, you might have to take a little bit of a few extra steps to solve it, so maybe factoring, stuff like that. But those are kind of what a lot of the problems are going to be based off of. So as of right now, are there any questions on 1 through 4? Okay, so we're going to take the last few minutes for you guys to try a few, because I can do these all day, and that will be a lesson and a half. But the main goal is to see, do you know how to do them? So you are going to try numbers 5 through 12. I will let you know that numbers 9 and 11 are the same thing. So once you do 9, you don't need to do 11. So these ones, they shouldn't be bad. Some of them, there's a bunch of proportions on there. I'm a big proportion fan in general, but your main goal is, if I said, hey, can you solve these? Could you solve them? Can you check them? I will kind of check in with people and make sure you are good from there. So I'm going to stop this.